Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is logarithm. What you are going to learn today is solving logarithmic equation. So let's begin. After completing the very lesson today, my dear student will be able to solve equations involving logarithmic functions. This is what I hope you'll be able to do after completing the very lesson today. So as usual, my dear student, in your favorite segment of the lesson today, I'll give you another interesting number. This number is 131. This number is so special, so unique, so amazing. In fact, I'll tell you what is amazing about this very number after completing my lesson today. So don't go away. To begin the lesson, my dear student, let us just move straight away to the examples where we start with the very first simple equations involving logarithmic functions. So example number 1, we asked to solve the following. Roman 1, it says log to base 5 of x equals to 2. Roman 2, we have log to base x of 60 equals to 4. Roman 3, we have log to base 3 of 243 equals to x. You can see the unknown letter x appear in a different places. Solution to this very problem, starting with the very first question, it says we are to find what will be x in this very equation. That meaning the solving the equation. So log to base 5 of x equals to 2. What we do all the time is to try to have a logarithm on both sides of the equation. Here I just have a constant number 2, but here is a logarithmic function. So try to have a logarithm on both sides of the equation. So to do that, let me just this number 2. I can write it as 2 multiplied by 1. Of course, this is obvious. Any number times 1 gives you that very number. So I'd just like to see 1 here. And this one, what I'm going to do next, remember properties of logarithm. If the base and the number are the same, you can take it as 1. So there I'm now replacing this one back by logarithm of 5 to base 5. Because this is log to base 5. So if I now, instead of this one, replace it by log to base 5 of 5, I think I'm okay. I'm very correct. This 2 times 1 is now the 2 times log to base 5 of 5. I just want to have log also by the right hand side. This is the meaning of doing this. So 2 is nothing but 2 multiplied by 1. And you replace this 1 by log to base 5 of 5 because the property says this is equals to 1. I just like to have also log to the same base as this base by my right hand side. So I continue. So what I'm going to do next, you can see this to 2. It can now move and becomes this very power, the second property of logarithm. So there you now have log to base 5 of x, that is my left hand side, equals to this 2 becomes a power to this number 5. So you have log to base 5 of 5 raised to 2. So what you now do after this, what I will now draw your attention is, by the left hand side we said log to base 5 of a number x is equal to log to base 5 of this 5 raised to the power of 2. So if this is true, surely this number x, whatever it is, will now be equal to the number of this logarithm because the two are equal. This is the same base 5, and logarithm of x, logarithm of 5 raised to 2 are equal. So surely this x must be equal to this 5 raised to the power of 2. That is, the numbers must be equal. So I can now say that this implies x here is equal to 5 raised to the power of 2. And what will now be 5 raised to the power of 2 is nothing but 25. So the value of this x is now 25. Let me just quickly answer the next question. Roman 2 says we are to find x if log to base x of 60 equals to 4. So what I will now do, I would like to see logarithm here by the right hand side as well. And it is base x. So this 4 can be 4 times 1. And you now replace this one by log to base x of x. Let me do that. So I have 4 times log to base x of x. I selected log to base x of x because the logarithm I have already by the left hand side is base x. So I'll continue. So this now 4 will now shift and become a power here to this x. So I'm going to have log to base x of 16 by my left, which I copied, equals to this 4 becomes this very power. So you have log to base x of x raised to the power of 4. If this is log to base x of 16 of x raised to 4, and the two are equal, then surely 16 will now be equals to x raised to the power of 4. So I can now write 16 equals to x raised to 4. And there I can now write 16 in index form, and I'll try to see that the power of that index number is also 4 so that I can equate the bases. So 16 is now 2 raised to 4 equals to x raised to 4. So as the powers are equal and these two index numbers are equal, then surely the bases must be equal. Then I can now write x is now equals to 2. This is the solution of this. That is the value of x, so that this log 2 base, the 2 of 16 will give you this 4. Let me just move to the next one. So the next question, that is Roman 3. Copying the given text there. What I will do first, already x that I wanted to find is just there. Is just there by the other side. So I will just try to simplify my left hand side. Whatever gives me finally, if it is a single value, that will now be the value of x. So in attempt to simplify this, I will now change this to 43 to index form. That gives me 3 raised to the power of 5. And this 5 will now come here to multiply log. So I'm going to have 5 log to base 3 of 3 equals to my x, and this log to base 3 of 3 gives you 1. So you now have 5 multiplied by 1 equals to x, and you now have just x equals to 5. This is the solution to this equation also. Let me just move and take another example. Example number 2, we asked to solve the log to base 5 of open bracket inside the bracket x plus 3 minus log to base 5 of another bracket, and inside is x minus 2 equals to 1. This is the given equation. Solution to this very problem, copying the given equation there. I would like to have logarithm by the right hand side also. So I will now replace this very one by log to base 5 of 5. Let me do that. So I have replaced this one by log to base 5 of 5 because this is nothing but 1. So what I'm going to do next is to apply the law of logarithm. This log minus this log, so I can now factor log to base 5 outside. That will give me open bracket after log to base 5. Then I will now take this divided by the second bracket. So as these logarithms are equal, surely the numbers must be equal. That is what is this bracket must be equal to this number 5. Let me just equate them. So you have x plus 3 over x minus 1 equals to 5. So what you now do next, you now solve this simple equation by cross multiplying. So I'm going to have 5 multiplied by x minus 1. There gives me 5 into x minus 1 equals to, then the x plus 3 times the one I have here, that gives me x plus 3. So I will now expand the bracket. That gives me 5x minus 5 equals to x plus 3. And collecting like terms gives me 4x equals to 8. This x now shifted to the left and this minus 5 shifted to the right. Is what gives you this 4x equals to 8. And divide both sides by 4. That gives you x equals to 2. So this is now the solution to this very equation. Let me just move and take one last example. The example is says solve this very equation. 3 log x equals to half log 16 plus log 2. The base of this logarithm is base 10. Solution to this very problem, copying the given equation. That is 3 log x equals to half log 16 plus log 2. So there you now applied the properties and the laws of the logarithm there. So you now have this 3 move as power, so you have x raised to 3. This 1 over 2 also move to become a power of 16. So you have 16 raised to the power of 1 over 2. Then copy the log 2. Then 16 raised to the power of 1 over 2 is nothing but square root of 16. That will give answer 4. So you continue. So you now apply the law of logarithm here by the right hand side. Log 4 plus log 2. That gives you log bracket 4 multiplied by 2. So 4 multiplied by 2 gives you 8. So you have log of x raised to 3 equals to log of 8. So surely as the base is the same and these logs are the same, then definitely x raised to 3 must be equals to this number 8. So you now have index equation that you now solve for x. And this x raised to 3 equals to 8. What we now do is to take a cube root of both sides to get x. So that gives you x equals to cube root of 8. And cube root of 8 simply gives you number 2. So the solution to this is now x equals to 2. This is how we now solve the equations involving logarithms. Well, so with these few examples, my dear student, I have come to the end of this very lesson. I hope you'll be able to solve the equation involving a logarithmic function. So let's just move quickly to the last segment. Must expand and explain what is amazing about the number 131. 131 is a prime number, and it is in position 32 in the sequence of prime numbers. If you are to write all the prime numbers, you discover that this 131 is in position 32, meaning it is number 32 prime number. And what is so special with this and this position, that if you add those digits in the number 131, that is 1 plus 3 plus 1, it gives you 5. And if you are to add it is position also the digits in the position, that is 3 and 2, it gives you the same result. That is adding the digits in the prime index, that is the position 32. If you add the 3 and 2, it gives you 5 as well. So the number, adding those digits in the number gives you 5. And it is prime index, that is the position of that very number. When you add those digits in the index, it gives you 5 as well. This is really interesting, which I believe you never noticed. There are other numbers like this, other prime numbers like this. Let me just share with you. The next number, that is 263, is another prime number. And in the sequence of prime number, it is in position 56. This 5 and 6, if you add, you get 11. Similarly, those digits in the number, if you add, it gives you 11. Another similar number is 16,661. It is in the position 1928 in the sequence of prime numbers. If you add those digits in the index and add those digits in the prime number, it's the same result that you're going to have. You can try it and see. This is really interesting. Maths is amazing. We see more of these things in mathematics in our subsequent lessons.